So, and we're going to be demonstrating here in just a little bit what we call the tactical resupply vehicle. And a lot of you, I'm sure, have seen the same drone that you see in these images in the lobby. And that vehicle we call the TRV 80 because it has an 80-pound payload lift. Now that's at sea level conditions, so it's going to have to be derated at altitude, but it has a significant payload capability. But we've been working on drones, different variants, ranging from 50-pound payload lift up to 300-pound payload lift. So basically, you can sort of pick pick the drone that best meets your requirements, right? The smaller the drone, the cheaper and more cost-effective it's going to be. Now, a lot of the things that we've been working on is autonomous operations. So a lot of the consumer-grade drones that people see, you'll see somebody with a controller, and they're basically manually flying the vehicle. One of the things that we've been working on with the military is to make it extremely easy to use, autonomous. In fact, you'll see what we call the easy button operation. So once you program a mission into the vehicle, you pretty much just push a button, and then it's going to execute that mission. And then if part of that mission is it's going to land at a remote site, then once it lands, somebody can interact with the drone. They just push the button, walk away, and it'll continue the mission. So you'll see that demonstrated here just in a little bit. These images and the video that has been playing out in the lobby is from a recent military exercise out at 29 Palms. So it's not quite at this altitude, but it was about 4,000 or 5,000 feet density altitude. And you can see both in these pictures and in the videos that basically the soldiers were able to operate it in desert, mountainous environments. So who are we, right? I work for a company called Survice Engineering, and we spell our name a little funny with a U instead of an E because we got our start doing all things related to survivability. So, everything from making helicopters more survivable, better body armor. And this program actually got started because we were looking at how to solve soldiers getting killed and injured from improvised explosive devices. And a lot of people don't realize that the majority of those IED incidents are associated with logistics. In other words, people moving food and ammo and water on roads, and people are mining those roads. So they're not necessarily combat incidents. It's more the hazards of just transporting material. So the more we can transport material autonomously with drones, basically we reduce the risk. But that same technology, of course, applies out here as well. I think I have the best job ever because I work basically for our company's Skunk Works division. So we do all the R&D. So, in addition to the drone technology, we're doing a lot of work with computer vision, neural networks, machine learning. So that's how we basically are bringing the autonomy part to the drone platform. So putting things in perspective, I think most of you have seen this drone. The picture of the small drone is a consumer grade drone. So, it's definitely, a consumer drone on steroids. The other thing that I wanted to point out, and this is more information on the TRV 80, is that you see a lot of information, FedEx, UPS, Google, they're all trying to, or Amazon, they're all trying to do drone deliveries. But to try to put things in perspective, all of those technologies that you see, generally they're trying to deliver a 5 or 10 pound package that, Amazon wants to deliver a box of shoes. So, even this drone is significantly larger than what you normally see that's in the news for these other organizations. But we call this our baby drone. We have other variants. So we have the TRV 150. And there you can see in the corner there, it's carrying 150 pounds of just, of weight. The one nice thing about this platform, it has twice the capability, right? Twice the lift, twice the range. But it's designed to fold up, and it will fit in that same Pelican case that you see out in the lobby. So it has the same logistical footprint. So a lot of interest in this platform. And again, more payload, especially when you get up into these altitudes. If you need more payload, this is gonna give you this additional payload, additional range. And then this is the TRV 300. If anybody heard in the news a couple of years ago about the hover bike and soldiers flying around on hover bikes, that was this vehicle. And you can see kind of the scale. It's about the size of a small car, so it gets very, very big. The reason we brought the small drone is we can fly it. It's still considered a Class 2 drone, so we can fly it in FAA space. Most of the operations we do here are all in military space where we have authorization to fly. But you can see that this technology does scale up. And again, the technology is designed to be fully autonomous as well. So the same software, the same autonomy, the same controllers, once you learn how to fly any one of the systems, it's the same across all the variants. Okay. So I talked about some of these things. I think this is my last slide before we go out for the demonstration. But a lot of the things that we're working on are things like autonomy, building in computer vision for obstacle avoidance, also precision landing. That was one of the things that Bert really needed for his application, was we need to be able to come in and GPS has a certain error associated with it, and it's really, really good. You can get to within a couple of feet just using GPS. But if you want to autonomously land and pick up a package, you need to be within inches, right? So we've been working with computer vision technology to augment that GPS. So you get us in the general vicinity, and then we'll use computer vision to literally land within inches of the designated location. We're working on gas generators, gas power generators. So all the vehicles you saw in the previous slides, the vehicle you're going to see here it's all electric, it's battery powered. But in instances where you need additional range, we can add a gas power plant. It will extend the range quite a bit, but of course it's more costly. There's more maintenance, so you have to, you have those trade-offs. You can see here we're doing a study where we're adding winglets to get some additional range. And then the last thing I'll point out is this was a test case where we're using our computer vision system. It's hard to see in that picture, but we basically have a drone, and we basically landed in the back of my truck. So we just had a target in the back of the truck, and then as the vehicle was coming in, we moved the truck so the drone would follow the truck and then land in the back. But that kind of is a really perfect use case for the application of coming in and landing at a remote site very, very precisely. Okay. So yeah, this is my last slide. So again, the applications is if you want to move material and you want to do it in austere environments, you want to do it autonomously, and you want to do it very quickly, right? Because these drones, again, will fly, the cruise speed on this TRV 80 is about 50 miles an hour. The larger ones go up to about 90 to 100 miles an hour. So, and it's a straight shot. So you can get to the location that you want to get to very quickly, autonomously, and I would say also cost effectively. So before we go outside, are there any questions? We designed the gen sets so that for the same weight of the battery pack, you get the engine, the generator,